All right, everybody, here we are on Chapter 11, Lesson 3, Measures of Variation. The learning objective is I can determine the measures of variation for a set of data. Now, this has a lot of vocabulary. So measures of variation include quartiles, first quartile, third quartile. We'll talk about the median being the second quartile. Interquartile range, and outliers. So we're going to figure out how to calculate those, how to find the quartiles. It sounds like a lot, but it's actually not too difficult. So the first thing I want to read is this. Measures of variation are used to describe the distribution or spread of the data. They describe how the values of a data set vary with a single number. A quartile is one measure of variation. So all of these things over here, these are all going to be numbers, so one number. It says look in a dictionary to find words that begin with Q-U-A-R, but let's just think about that for a minute. I was thinking about quarter, and I was thinking about a quart, or maybe quarterly. Quarter is a fourth of a dollar. A quart is a fourth of a gallon. And quarterly is like a fourth of a year. So based on all of these definitions, this idea of the root here, core, the quartiles would be something to do with 1/4, I would say. So quartiles are values that divide a set of data into 4 equal parts. So when we talk about our data, we're going to be talking about dividing data into 4 parts. We've already divided it in half at the median, but now if we divide it in half, we could divide it 2 more places. So this would be like quartile 1. The median is quartile 2, quartile 3, and then this last part would be the 4th quartile. So 1, 2, 3, 4 quartiles. So that's going to be one of our main ideas. How do we divide our data into 4 parts? And then we're going to put a number for quartile 1 and quartile 3. Also quartile 2, but we'll call that the median. So this example here says James asks his classmates how many hours of TV they watch on a typical day. So here's our little plot right here. Divide the data into 4 equal parts. Draw a circle around each part. So these 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 pieces of data divided into 4 parts would be 4 pieces of data in each part. So when it says how many data values are in each group, it should be 4. So it's like here's the first quartile, then these 3 ones, and then we have to get 1, 2. That would be the second quartile. This would be the third quartile, and then these last 4 would be the 4th. So we are going to find a way to divide our data into 4 quartiles. Let's get started. Reviewing the measures of variation. Quartiles are values that divide the data set into 4 equal parts. First and third quartiles. The first and third quartiles are the medians of the data values less than the median and the data values greater than the median, respectively. So again, if you have, well, actually, it shows down here in this number line. If you have all of your data here, the median splits it in half, and then half of this lower half is Q1, quartile 1, and then half of this upper part of the data is quartile 3. So when it talks about their medians of the data values below the median, it's like we're just going to find the median of this half, and we're going to find the median of this half. Interquartile range is the distance between quartile 3 and quartile 1. So how far apart is this number and this number? And then the range is the difference between the greatest and least values. So the range is the difference between this smallest value in the data and the largest value in the data. Measures of variation of a data set are shown below. And again, let's review this. This is the median, the halfway point, the center of the data. The median of the data values less than the median is the first quartile. We call it Q1. In this case, it'd be between 1 and 2, so that'd be 1.5. And remember, we calculate that like this if it was a more difficult number. So you find the sum and divide by 2. So that would be 3 divided by 2. Then here, the median of the data values greater than the median is the third quartile. So it's right between 6 and 7. And again, if it was more difficult numbers, you would want to do this. And that gives you 7.5. I'm sorry, 6.5. 1/4 of the data lie below the first quartile, and 1/4 of the data lie above the third quartile. So 1/2 of the data lie between the first and third quartile. And between the first and third quartile, that's the interquartile range. Between the minimum and the maximum data value, that's the range. So add that in, because that gives you a good picture of what interquartile range is and what the overall range is. Let's do an example here where we find this stuff. It says, find the measures of variation for the data. Now, here's your data. Animal speed, so how fast these animals can go. So what we have to do is, you know how to find the median, you have to order the data from least to greatest. So all of these numbers, 1, 8, 25, 30, 50, 70, are ordered least to greatest. Going 3 this way and 3 this way puts the median in the middle. So you'd have to do 25 plus 30 divided by 2, and that gives you 27.5. So on this side here, what's the middle of this lower part of the data? That would be 8, so that's quartile 1. And what's the middle, or the median, of the upper part of the data? That would be 50, so that's quartile 3. So the range would be the difference between 1 and 70. So 70 take away 1, the range is 69. The interquartile range would be the distance between Q1 and Q3. So 50 take away 8, which is 42. So the range is 69, the median is 27.5, the first quartile is 8, the third quartile is 50, and the interquartile range is 42. And those are the measures of variation for the data. Now we're going to do one together. So now we have to do all these measures of variation for this data set. So the first thing we have to do is order the data from least to greatest. Let's make a note about that. When finding measures of variation, order data from least to greatest. All right. Now, by the way, this is going to be like your other tips to refer back to. When I want to do this for interquartile range, I'd put Q3 minus Q1. All right, so let's order this data from least to greatest. I see numbers in the 50s, and there's nothing in the 40s. So let's look at the 50s first. It would be 56, 57, 58, 59. Then it hops to the 60s, 61, 62. All right, then there's a 64, 67, and 71. Now let me count and make sure I have them all. 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So half of 10 means 5. So there are 5 on the left, 5 on the right of the median. So this is going to be the median between 60 and 61. So the median here, I know that right between 60 and 61 is 60.5. But if you didn't know that, you could use your calculator and you could do 60 plus 61 divided by 2. 60 plus 61 divided by 2 is 60.5. So our median is 60.5. Now, this side of the data, what is the center of this? There are 5 pieces, so 2, 2. This middle one would be quartile 1. And here we have 5 pieces of data, so this third piece in the center would be quartile 3. So now, to find the range in the interquartile range, the range would be the 71 minus 56. So the greatest piece of data minus the smallest. And the interquartile range would be quartile 3 minus quartile 1. So 64 minus 58. And when you calculate these, 71, 56, that would be 15. In the interquartile range, probably should be doing this mentally, but you know. All right, so here's how you write your answer. You write it out like this. So we can say the range is 15. Interquartile range is 6. Q1 is 58, comma, median is 60.5, and Q3 is 64. And that is a list of the measures of variation. Now, of course, when we go to the next page, there's always going to be something that makes things a little more complicated, and that is going to be finding outliers. We're also going to be analyzing data, so we're going to be saying, we're going to compare like animals to fish or something like that, and we'll compare the different data, the measures of variation. But first, let's talk about outliers. An outlier is a data value that is either much greater or much less than the median. If a data value is more than 1.5 times the value of the interquartile range beyond the quartiles, it is an outlier. So this right here is the key. And I want to make a visual picture of this for you. So here's what it means. If you have, oh, I wonder where I can fit it. Maybe I'll fit it right here. So if you have your data here, and you have your median, and you have quartile 1 and quartile 3. Outliers are data values that are 1.5 times the interquartile range, lower than Q1 or greater than Q3. So an outlier down here would be if you took quartile 1 minus the interquartile range times 1.5. That would be an outlier down here. An outlier of data up here would be if you took Q3 and you added whatever the interquartile range times 1.5 is. So the trick to this whole thing is to find interquartile range, multiply it by 1.5, and if you have data that's less than that much below Q1 or more than that much before Q3, then that data is considered an outlier. Let's look at some examples, and then I think you'll get a better picture of what I'm talking about. So here's example 2. The ages of candidates in an election are 23, 48, 49, 55, 57, 63, and 72. Name any outliers of the data. Well, let's first list these numbers in a line, and they're already in order for us. So 23, 48, 49, 55, 57, 63, 72. So the first thing we have to do is find the measures of variation. Now, the center of this data, there are three, this is 4, 1, 2, 3, 4. This would be the median. Now, on this half of the data, this side of the median, this would be the center, so that's Q1. On this half of the data up here, 63 would be the center, so that's Q2, or Q3. So now you find the interquartile range. So the interquartile range would be 63, take away 48, which is 15. Once you have the interquartile range, this is the key. Multiply the interquartile range by 1.5. So 15 times 1.5 is 22.5. So now, that's 22.5. We subtract 22.5 from the first quartile because we want to see if there's anything. So 48, oh, it does it right here. 48 minus 22.5 is 25.5. So 25.5, if there's anything less than that, which there is, it's an outlier. Now, if there's anything 22.5 greater than 63, right here, so Q3 plus that magic number, 22.5, is 85.5. But that's over here, and there is not any data that's greater than that. So our only outlier is 23. The only age beyond the limits is 23, so it is the only outlier. All right, now, before we do the next thing, I want to write a little help sheet, a little, not help sheet, but description. Finding outliers, and we might have to kind of write small, finding outliers. So what you need to do is, first, multiply IQR times 1.5. Now that's going to give you a product. I'm going to call it the magic product. Right here, 22.5 was the magic product. All right, so then you subtract that product from Q1. Any data less is an outlier. You add that product to Q3. Any data above is an outlier. So, whatever this magic product is here, if you have data more than less than Q1 or more than that greater than Q3, it's an outlier. Man, that is really hard to put into words. So let's do another example. The lengths in feet of various bridges are 88, 250, blah, 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 blah. Name any outliers of the data set. So let's order this data from least to greatest, which, wow, they already did that for us. So 88, 251, 275, 354, 1,121. Now, we are going to have to multiply the interquartile range. So to get the interquartile range, we need to find the median in quartile 1 and quartile 2. Now, in 5 pieces of data, 1, 2, 3, 1, 2, 3, this is going to be the median. Now, I like to almost cover up this to find the Q1 down here. What's the median of this? It's whatever's between here. That's Q1. And up here, above the median, whatever's between these two, that's going to be Q3. So, 88 plus 251 divided by 2 is going to give us Q1. This 354 plus 1,121 divided by 2 will give us Q3. So let's find that out right now. Q1, 88 plus 251 divided by 2. So 169.5. Q1 is 169.5. Let's talk about Q3. 354 plus 1,121 divided by 2, 737.5. All right, so we need to find the interquartile range. So the interquartile range is going to be 737.5 minus Q1, 169.5. So what is that interquartile range? 737.5. Whoa, hello. 737.5 minus 169.5. Interquartile range is 568. Now we need to find the magic number, that magic product, 568 times 1.5. So multiply IQR times 1.5 to get the magic product. I'm going to put a star here for a little puff of magic. 568 times 1.5 is 852. Now, if we do Q1 minus 852, if there's any data less than that, it's an outlier. Or Q3 plus 852, any data above that is an outlier. So Q1 is 169.5, Q3 737.5. So 169.5 plus 852, oh, I'm sorry, minus 169.5 minus 852. Oh, that's giving us, I shouldn't have even done that. It's giving us a negative number. So we don't have any negative numbers way down here. This is not an outlier. What about this? 737.5 plus 852. That's going to give us a huge number. 1,589.5. We don't have anything greater than 1,589.5. So, man, we did all that work, and there are not any outliers. So, name the outliers. There are none, which gives me a grr face because we did all that work and there aren't any. All right, let's look at example 3. The table shows a set of scores on a science test in 2 different classrooms. Compare and contrast their measures of variation. So when you compare and contrast, you're going to have to do the measures of variation for this data, the measures of variation for another set of data, and then compare them. So watch how they did this. You have room A and room B. Room A, the range. So the greatest minus the least piece of data, that gives you 35. You know what? You would need to list this out in order. So in order to look at this data, let's list it out. So this is going to be room A, and this is going to be room B. So room A, the smallest piece of data is 67. Okay, 67, 72, 78. All right, now we go to the 80s. 80, 84, 87. And then 92. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. What did I miss? Oh, 65 down here. And 100 up here. Okay, now room B. So room B is in the 60s is the lowest, 63. And then you have in the another 60, 65. In the 70s, you have 73, 79. In the 80s, 81, 83, 87. And then 93, 98. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so range, 100 take away 65, 98 take away 63. Median, okay, we had 9 pieces of data, so it should be the 5th one. 1, 2, 3, 4, 5. This is the median. 1, 2, 3, 4, 5. That would be the median. So 80 and 81. Quartile 3, quartile 1. Okay, so if you cover this up, quartile 1, it's between 67 and 72, between 65 and 73. On this side, there are 4 pieces of data, so it's between these, and here between these. So when you see what they did up here, 87 plus 92 divided by 2, that gave this 89.5. Same here, adding, divide by 2, add, divide by 2, add, divide by 2. So you got all your third and first quartiles. The interquartile range would be this minus this, and this minus this. So now, when you do the compare and contrast, you say how they compare in range, median, quartiles, and interquartile range. So it says both classrooms have a range of 35. But room B has an interquartile range, right here, of 21, and room A has an interquartile range of 20. There are slight differences in the medians and third and first quartiles as well. But everything, I would even say at the end, but all of the data is very close. So we're going to do one practice of this, and then we'll go into the guided practice. So this right here is our practice of comparing 2 sets of data. Temperatures for the first half of the year are given for Antelope, Montana, and Augusta, Maine. Compare and contrast the measures of variations of the 2 cities. So let's do, we'll do one up here, Antelope, and we'll do Augusta down here. All right, so Antelope is up here, and it looks like we have to order from least to great. Oh, wow, they already ordered it for us. Cool. 21, 30, 42, 58, 70, 79. They already ordered this? Yes. 28, 32, 41, 53, 66, and 75. So let's find the median. It's going to be between these 2. So our median, 42 plus 58 divided by 2 equals, half of 100 is 50. So our median is 50. Now, if you look on this side, the median here is 30, so that's Q1. And if you look on this side, the median here is 70, so that's Q3. So interquartile range and range. Interquartile range would be 70 take away 30, which is 40. And then the range would be 79 take away 21. 9 take away 1 is 8. 7 take away 2 is 5. Okay, now let's get it for this data. So our median, there's 3 and there's 3. Our median is here. So 41 plus 53 divided by 2. 41 plus 53 equals, divided by 2 equals 47. So that's our median. On this side of the data, the middle's 32, that's Q1. This side of the data, the middle is 66, that's Q3. So the IQR is 66 minus 32. And the range is 75 minus 28. $47. All right, so now we have to compare. So when we compared back here, it talked about range, interquartile range first. So the range is a little bit different. The range for Antelope is a little higher than Augusta. So Antelope was 58, Augusta was 47. Now, interquartile range. The same, so antelope was higher. The same goes for interquartile range with antelope at 40. This is 40 degrees, and Augusta at 34. Now, quartiles in the median, it's higher on quartile 3. The median's a little higher. The only thing that's different, this pattern continues for quartiles, except quartile 1 is a little, there's the bell, greater for Augusta by, it's only 2 degrees greater, see 30 and 32. So that's how you write a description to compare. You make sure that you give the numbers and you say if things are close or greater or less. Now it's time for the guided practice. Let's find a partner. There are only a couple problems to do in there. All right, with your partner, you are going to do all of number 1 and all of number 2 for guided practice. With number 1, you're using this data over here, the average wind speeds for cities in Pennsylvania. You have to find the range, the median, first and third quartiles, the interquartile range, and see if there are any outliers. Make sure that you look back at this when it's time to figure out if there are any outliers, so you can follow these steps here. For number 2, you have to basically do the same thing. They give you palm tree heights here, and then pine tree heights here, and you have to compare and contrast the measures of variation. So just like up here, you have to find the median and the quartile 1 and 3, the interquartile range and the big range for both sets of data, and then you have to write like a few sentences describing what the range and interquartile range, how they're similar, how far apart they are between the palm trees and the pine trees. So start with number 1, work this out together, and then check it with this video. Now the first thing I remember to do is, when finding measures of variation, order data from least to greatest. So the first thing I'm going to do here is take this data and order it from least to greatest. All right, so it looks like the 7s are the smallest, 7.5, 7.6, 7.7. So we'll go in that order, 7.5, 7.6, 7.7. Then there's the 8s, there's just one 8. For the 9s, you have 9.0 and then 9.5. And then the largest is 11. So we need to find the range, and to find the range, it's the greatest piece of data minus the smallest piece of data. So 11 minus 7.5. 7.5, 8, 9, 10, 11. So that would be 3.5. By the way, I'm getting out my calculator here because I put it away. So when we need it, we have it. So 3.5. Now the median and the first and third quartiles. So what do we have here? 3, 4, 5, 6, 7. Make sure I did it. 1, 2, 3, 4, 5, 6, 7. Yep, I've got everything. It's an odd number, so there is a middle. So this 8.9 has 3 to the left and 3 to the right. So that's our median. So then in the middle of this side, if I cover that up, this middle number would be the first quartile. And on this side, this middle number would be the third quartile. So this data was easy. We didn't even have to find any averages in there. So the median, first and third quartile, median is 8.9, Q1, 7.6, Q3, 9.5. Now find the interquartile range. So 9.5 minus 7.6. 1.9. And identify if there are any outliers. So remember, with outliers, you find that magic number, the magic product, the IQR times 1.5. Subtract that from Q1, add that to Q3. Anything lower or higher is an outlier. So the interquartile range, 1.9 times 1.5. So 1.9 times 1.5. This is going to give us our magic number here. 1.9. So 2.85. Let's see here. This 7.6 minus 2, it's almost minus 3. It's going to be lower. It's going to be out here, 7, 6, 5, 4 point something. So 7.6 minus 2.85 is this 4.75, but there's nothing down that low, so there is not an outlier that way. What about 9.5 plus that magic number, 2.85? That would be up in the 12s, and there's nothing up that way. So there are not any outliers. All right. I hate when you do all that work and there aren't outliers, but that's okay. So now you're going to do number 2. You have to do the palm tree data and the pine tree data. So I might do the palm here and the pine down here. And then we have to write our description here where we compare all of the measures of variation. Okay, go ahead and do that and then check with the video. So when I look at these palm trees, the smallest is 15. So 15, and then the 20s. So there's 22, 25. In the 30s, there's just 30, just 40, and then 50. So I have 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. Okay, now down here with the pine trees, looks like 45 is the smallest. Nothing in the 50s. There's a 60. Nothing else in 60. So 70 and then 2 75s. And then the 80. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so let's do the palm tree measures of variation. In the middle of 6, it would be here, 3 on each side. So what's in between 25 and 30? If you don't know, add them up and divide by 2. I think it's 27.5. So that's going to be 27.5 is our median. Okay, so now this side of the data, what's the middle here? 40, that's Q1. And then this side of the data, what's the middle? 22. Dude, that's supposed to be Q3. All right. So Q1, median, Q3. What is the range in the interquartile range? So the range is the difference between 50 and 15. And the interquartile range is the difference between 40 and 42, or 22. 20, 30, 40, 50, so that'd be 35 for the range. And 22, 30, 40, 8, so 18. Okay, so now let's do all of that. Let's get all of our data for the pine. So down here, the center of 6 pieces of data will be here. So that would be between 70 and 75, it would be 72.5. But how do we do that? 70 plus 75 divided by 2. That median is going to be 72.5. Just to double check. Okay, so now this side of the data, the middle is 75. I'm going to label it correctly this time, Q3. The middle of this side is 60, so that's Q1. So let's find the range in the interquartile range. So range would be the difference between 80 and 45. 50, 60, 70, 80, so that's 35. The interquartile range is the distance between 75 and 60. So that would be 15. All right, now we have to write a comparison. So the ranges are the same. The interquartile range is a little bit greater for the, what was this, palm trees. So let's start by talking about the range. The range is, what was it, 35 for both trees. Okay, so now median, oh my, look at that. So the overall data is higher. Pine trees are overall taller than palm trees. So what we could say is, but they do have a similar range. Okay, so overall, the quartiles are greater for pines. So I'm going to say Q1 median, Q3 than palms. So palms had 22, 27.5, and 40. However, so overall the quartiles are greater for pines than palms. However, the interquartile range is close. So it was 15 for pine, 18 for palm. Okay, so we wrote about the range, we wrote about the quartiles, and then we wrote about the interquartile range. So now we're moving on to independent practice. For the independent practice, you are going to do 1, 2, and 3. And let's just take a look at this. Number 1, you're using this data. So it has a lot of data. This time you have 10 pieces of data. Find the range, median and quartiles, IQR, and outliers. For number 2 and 3, you need to find the median, first and third quartiles, and interquartile range. So here's the deal. We're not doing number 4 where you're comparing 2. We're only going to do 1 and 3 at this time. So go ahead and do those and then check your answers. Let me walk you through all this work here. I ordered numbers from least to greatest for number 1. So the range is the greatest, 1,465, minus the smallest data, 437. So here's the range, 1,028. The middle of this data is right here. So I did 893 plus 954 divided by 2. Or not plus, but no. That should be a plus sign. And that gave me 923.5. Then on this side of the data, the middle was 513, so that's Q1. And on this side of the data, the middle was 1,038, so that's Q3. So the interquartile range is 1,038 minus 513, which is 525. For the outliers, I found the magic product, IQR times 1.5. So 525 times 1.5 was 787.5. Took that away from Q1, and that was a negative number. So there wasn't anything down there, no outliers there. Took Q3, added that magic number. That was 1,825, and there weren't any numbers greater than that. So there were not any outliers. For number 2, I ordered numbers from least to greatest. The center was right there in the middle, 26. Q1, I didn't have to do any special work for those two. The IQR, 38 minus 19. For number 3, I did have to do work to find the median. So 346 plus 369 divided by 2 gave me the median. Q1 was right there in the middle, and Q3 was right there in the middle. Subtract to get the IQR is 124. Time for the reflection. The lesson 3 reflection for determining measures of variation for a set of data goes like this. First, use words to explain how to find the measures of variation. Range, first, third quartile, IQR, and outliers. For number 2, find the measures of variation for the data. So show your work here and then write the answers down here. Okay, good luck.